Alright, today we're going to be looking at sketching y equals ax squared plus bx plus c using factorisation. So basically what we're going to be doing is that we're going to factorise this in order to find our x-intercepts, which will help us sketch a graph. So let's get started. First of all, if we have the general rule y equals ax squared plus bx plus c, just like with straight line graphs, the constant is the y-intercept. So whatever number that c is where the graph will pass through the y-axis. Now, we'll start with a reasonably simple one. Y equals x squared plus 6x plus 5. Alright, so my first step is to identify y-intercept, y-int. As we can see, this is plus 5, which means the graph will pass through the y-axis at 5. Okay. Now, our next step is to find the x-intercepts. Now, when we find the x-intercepts, what we generally do is that we let y equal 0. So what this will turn into is 0 equals x squared plus 6x plus 5. Hopefully this looks very familiar. When we have 0 on one side, we are able to solve for x. Whatever those values are is what the x-intercepts are going to be. Alright, so the next step is to factorise. So let's look at this. We need to find two numbers that multiply to equal 5 and add to equal 6. So multiply to equal 5, add to equal 6. I know that's 5 and 1. 5 times 1 is 5. 5 plus 1 is 6. So this will factorise into x plus 1, x plus 5. Therefore, x is equal to -1 and x is equal to -5. These are my x-intercepts. These are x-intercepts. Alright, now we have the information we need now. So let's draw a graph. Alright, here we go. So, here's our graph. Let's find our key points, y and x. We said that the x-intercept was at 5, so we go up to 1, 2, 3, 4, 5. So it'll pass through there. We said the x is -1 is 1, -2, -3, -4, -5. So these 3 points tell us whereabouts the intercepts are. There's one last thing, is we don't know where the turning point is. So to do that, we find to find the turning point, it's halfway between the two x-intercepts. Now, so halfway between there, so it's -5 minus 1 divided by 2 equals -3. So x equals -3 will be where the turning point is. But how do I find the y value of it? Well, the way we do this is by substituting x equals -3 into the equation. So we will have y equals -3 squared plus 6, -3 plus 5. Make sure that you put brackets around it, or else you might get the wrong answer. -3 squared is 9. 6 times -3 is -18, plus 5, which is 9 minus 18, which is -9, plus 5 is -4. So the point -3, -4 is our turning point. -3, -4. This is the x value, this is the y value. So I'm going to show that on the graph now. So here it is. And then it's just a matter of connecting the dots in a curved manner. And we're done. Oop. So that's what it should look like. I'm going to label this just so the person who's marking it knows this is the turning point, -3, -4. Alright, so to recap, we find the y-intercept, we find the x-intercepts by letting y equal 0, and factorise to solve. We factorise to solve. Once we've solved, we find the midpoint of the two x-intercepts, and then substitute to find the turning point, and then we connect the dots to get our answer. Alright, I'm going to try a different one. Y equals x squared plus 6x plus 9. So this one, this will be factorising into x plus 3 all squared. Obviously first we're saying this is the y-intercept. So we know the graph is going to pass through +9. We know if I let x equals 0, sorry, y equals 0, 0 will equal to x plus 3 all squared, so there's only one solution. That means there's only one x-intercept. But parabolas generally have two intercepts. So if you see a scenario where you have one solution, what this means is the quadratic graph actually touches the x-intercept at that point. So it will look like this. So it passes through 9 on the y-axis, and it touches the x-axis at -3. That way there's only one intercept. It still crosses through it, but it only does it once. And that would be all you need to include for that graph. Coincidentally, it's also the turning point, isn't it? So I might label that to show that it's a turning point. Alright, so that's all there is to that. Essentially, what you need to make sure is that you've got your factorisation down pat and you're following the correct steps. So, good luck.